So in this video, I'm going to do a pretty robust review of imaginary numbers, although I have assumed that you've seen this before, so I'm going to go through this kind of quickly. So, okay, imaginary numbers, so just to remind you, so it's the number I, which equals the square root of -1. That is what an imaginary number is. It is just the square root of -1. Now, the implication here is that if I have I squared, then if I remember, whenever you square a square root, you just get whatever is under the square root. So I squared equals -1. This is actually a pretty important thing. It's probably like one of the more important things to remember about imaginary numbers. Now, complex numbers are related to imaginary numbers. Complex numbers are numbers with the form a plus bi. The a and the b, those are going to be real numbers, but the b, so it's basically got like an I attached to it. That's how you know you're dealing with a complex number. The a is the real part, and then the bi, that's the imaginary part. And just to make it clear, so when are two complex numbers equal? So they're equal, so if I have a plus bi equals c plus di, then that would mean that a equals c and b equals d. That's the only way that they can be equal. Now, something that is often forgotten when you're working with like square roots of negative numbers is that what a square root of a negative number means is that it really means the square root of -I times the square root of that number. And remember, the square root of -1 is just I, so this would become I times the square root of a. Okay, so with that in mind, let's just review a few things about square roots of negative numbers. So the first thing that I'll do when I have a square root of a negative number is I'll just pull the I out, and then I'll go ahead and I'll simplify the square root. And when you simplify a square root, so you can think of what is the largest perfect square that divides 12. In this case, that would be 4, so I can break 12 into square root of 4 times square root of 3. So this would be 2i times the square root of 3. Got it? Okay, why don't you try b? Okay, so this is going to be I times the square root of 25, so then this is just 5i. Okay, so where this really matters is when you're working with like operations. The first thing that you want to do when you are doing any type of operation is you want to pull out the I, like you see here. Now that I know how to view this operation, I have I times I, which is I squared, and then square root of 5 times square root of 3, so I just multiply the numbers underneath the radicals. So I have I squared times the square root of 15. And what was I squared, my friends? It was -1, so I can write -1 times the square root of 15, or I could just write negative square root of 15, whichever you prefer. Okay, so same idea with this next one. First, you've got to take the i's out. I would recommend that you try this one on your own and then hit play when you think you've got it. Okay, so if I work through this one, so first I'll take out the i's. And the thing that I notice right away with this is that the i's cancel out. And so from here now I can just go ahead and simplify these square roots. So I am pulling out the largest square root that goes into each. So this becomes 2 square root of 3 over 3 square root of 2. And you can't simplify these any farther. These are out of the square root, these are under a square root, so that's just what it is. Okay, so what about this one? Once again, I would recommend that you just pause here, give this a try, hit play when you think you've got it. So this one, I'll rewrite just the top. The bottom is just 3, right? So then I can rewrite this as, let's see, square root of 25 times the square root of 2, all of this over 3. So this is going to be 5i times the square root of 2 over 3. Okay, now to add and subtract real numbers, you really just add the real parts and the imaginary parts, similar to how you would do with like terms. So if I have this first example, 2 minus 6i plus 8 plus 2i, so the real parts get added and the imaginary parts get added. So if I add 2 plus 8, that's 10. If I take -6i plus 2i, that becomes -4i. Now, the second imaginary number, I have 5 minus 7i minus -4 plus 2i. I highly recommend that you actually distribute this negative, because it's very normal that your brain can work very fast and then end up making a mistake. That is how my brain works. See, I almost made a mistake. So I will go ahead and I distribute the minus sign, and now I can finish this. So I've got 5 plus 4 is 9, -7 minus 2i is -9i. So there you go. Now, when you multiply imaginary numbers, a lot of times it's just going to feel like foiling. The thing to remember, though, is that when you have I times I, that is I squared, which becomes -1. So just to kind of refresh your memory on that. So we're going to multiply these together. So first I'll multiply the 2 times the 3, which is 6. Then I'll multiply the 2 times the -5, which is -10i. Then I'll multiply 4i times 3, which is 12i. And then finally, I'll take the 4i times the -5i. So I want you to notice here, right, I'm doing I times I. So you've got to keep that in mind. So 4 times 5 is -20, or 4 times -5 is -20. And then the I times the I, can't speak, it's I squared. Okay, so now we've just got to simplify all of this. So this becomes 6 plus 2i. And then this -20i squared will become just plus 20, right? Because I squared is equal to -1. So this effectively just flips the sign of whatever this number is. So ultimately my answer is 26 plus 2i. Okay, so I highly recommend that you pause the video. Remember, I always say math is not a spectator sport. You try this one on your own just to kind of review it and then hit play when you think you've got it. Okay, so if I go through and I multiply this, let's see, I've got 4 times 3, which is 12. I've got 4 times -2i, which is -8i. I've got -5i times 3, so this is -15i. And this is -5i times -2i, so that becomes plus 10i squared. So this becomes 12, let's see, minus 23i minus 10. So I have 2 minus 23i. That would be the final answer. Okay, and I've got just one more of these. Again, I highly recommend that you just pause the video here, give this a try, hit play when you're ready. So if I multiply this out, I get 9 minus 6i plus 6i minus 4i squared. You'll notice that the 6's drop out, so I'm left with 9 plus 4, and this just equals 13, so it's just a number. Okay, so the next thing that I want to review is the conjugate. So the conjugate is found by just, you flip whatever the symbol, the sign in the middle of the expression is. So 4 plus 2i, the conjugate of this would be 4 minus 2i. So it's just that middle symbol. So when I look at -3 minus 4i, this would become -3 plus 4i. I don't care that the first term is negative. I just care about that symbol in between. And then for C here, so I thought I'd throw a curveball in. So you can actually view this as 0 plus I. So if I wanted to come up with the conjugate then, so the conjugate will be minus I. And why does this matter? Well, to find the quotient of two complex numbers, you need to multiply by the quotient of the denominator. Sorry, did I say quotient? I meant conjugate. Conjugate, my bad. Okay, so we'll keep going. All right, so let's find the quotient of this next one. So I find the conjugate of the denominator. So the conjugate would be 2 minus I. So that's what I want to multiply by. Whatever I do to the bottom, I also have to do to the top. So I just multiply all of these pieces together now. So I'd recommend that you just try this on your own just to make sure that you get some more multiplication practice and hit play when you're ready. So if I multiply these, I get 6 minus 8i minus 3i plus 4i squared, and then 4 minus 2i plus 2i minus I squared. Okay, so now we've got to simplify some things. So let's see, this will become 6 minus 11i minus 4, and this will be 4 plus 1. So, okay, let's talk about this now. So this becomes 2 minus 11i over 5. And maybe you're thinking, great, I'm done. So technically, this is not an imaginary number. An imaginary number has two parts, and since we have this whole thing over one number, this is now one number, so we don't view this as an imaginary number. So generally when you do a problem like this, you need to take the time to actually break the fraction up, like so. And you could put the I there. I think a lot of books will put like the I there. Tomato, tomato to me, but I think properly you put the I there. Okay, so what about this other one? So what would be the conjugate in this case? Well, we just did that problem, right? So the conjugate of I would be negative I. So I can multiply the top and bottom by that to get negative 5I over negative I squared. So this becomes negative 5I over negative 1. So this just becomes negative 5I. And that's it. Okay, now one of the key things about I, or like an interesting thing with it, is that its powers cycle through. So if I start with we know that's the square root of negative 1. And we already talked about what happens when I have I squared. That equals negative 1. Now, what would I to the third be? Well, to get I to the third, you just multiply the previous power, negative 1. You multiply that by another factor of I. So what is negative 1 times I? That's just negative I. Okay? And now, what is I to the fourth? Well, I to the fourth is found by multiplying this previous step. So maybe I'll just write the details here. Negative I times I. So I multiply the previous step by I again. This equals negative I squared. So I squared is equal to negative 1, but there's a negative in front here. So I'd have negative 1, which just equals 1. Okay, and then what happens when I go to I to the fifth then? When I go to I to the fifth, so I multiply 1 times I, and now I have started the cycle over again. So I to the fifth just equals I to the sixth will equal negative 1, I to the seventh equals negative I, and I to the eighth equals 1. So I just kind of cycles for forever. And so knowing this, we can simplify these larger powers of I really down to one of those 4 results. So how do you do this? So to do this, you actually really want to rewrite the power using some rules of exponents. So what is the largest? Maybe I'll just write it out. So let's see. Let's say I have I squared. So 2 goes into 17 how many times? 8 times, right? And there's a remainder of 1. Do you see how I broke that up? So I took I squared, and I was basically just asked 2 goes into this number how many times? 8 times, and then I have this last remaining I, so that's fine. So in breaking up my exponent like this, I actually make this a lot easier to deal with because I know that I squared is negative 1. And so negative 1 to an even power, what is that? That's just 1, right? So this just becomes then 1 times I, so this will just ultimately equal I. Okay, so why don't you try that with B? You try to set this up the same way, and then hit play when you're ready. Math is not a spectator sport, so give it a try. All right, so I've got I squared. How many times does I squared go into 28? It actually goes in evenly, 14 times. Okay, so now I'm going to take I squared. I know that's equal to negative 1. So what is negative 1 to the 14th? Is that going to be positive or negative? It's going to be positive. So that whole thing just equals 1. Okay, so let's change it up a little. I've thrown in a little bit of a curveball here, so I've got a negative exponent. So what do I do now? Okay, so there's actually a pretty clever trick you can do to figure this out. What we're going to do is we're going to multiply this by 1, which does nothing, right? If I multiply by 1, that doesn't change the value of this expression. But I know that 1 is equivalent to I to the fourth. Dun, dun, dun. So I could rewrite this now as I to the negative 14th times I to the fourth. So what does that do? Well, I can add the exponents, and that gives me I to the negative 10th. Okay, so I still have a negative exponent. That doesn't really help me. So here's the question. How many times... So think about it this way. What multiple of 4 can I add to this to get a positive number? I'll put it to you that way. Well, I could multiply by still I to the fourth, but I could take I to the fourth to the fourth. This is still equal to 1, right? This just ends up being I to the fourth is 1, 1 to the fourth is 1. So I've done nothing to change the value of the problem. But check it out. Now I've got I to the negative fourth times I to the 16th. And now when I add the exponents, this whole thing actually just reduces to I squared. Kind of crazy, right? So it's an interesting trick. And then what is I squared? It's just equal to -1. Okay, so with that in mind, why don't you try D just to make sure you've got it and hit play when you're ready. Okay, so for this one, I'm going to have I to the -5th, and I want to multiply this by 2 multiples of I to the 4th. So I want to multiply this by I to the -5th times I to the 8th, which is equal to I to the 3rd. And what is I to the 3rd? I to the 3rd is equal to -I, so we're done. Okay, and the last thing that I just want to briefly remind you of are quadratic equations and when they come up with imaginary numbers. So I have just a couple of different techniques I want to review while we do this. So I want to solve x squared equals -25 using the square root property. So if you forgot the square root property, don't worry, I'm going to remind you right now. So I've got x squared. So to solve this, I take the square root of each side. The thing that everybody forgets about the square root property is that when you take the square root of the number, you need plus or minus in front of that number's square root. Very important. So now I can go ahead and solve this. So I have x equals plus or minus, and now what is the square root of -25? It's 5i. And so those would be my two solutions. X equals 5i, x equals -5i. Okay, so if you forgot that, I think it might be good for you to try this on your own. So I'll just tell you the one thing with the square root property, if you want to use it, is that to use it, you need to have the x on one side and the number on the other, like this. So you always have to set up like this if you want to use the square root property. So from here, I would just recommend that you pause the video for a second, just try it on your own just to kind of refresh your memory and then hit play. So I can take the square root of both sides. Don't forget the plus or minus. So now I have x equals plus or minus. So let's see, I can rewrite this as -25 times 3. So this is x is going to equal plus or minus 5i times the square root of 3. And those would be my two solutions. So you would probably a lot of times want to break them out. I think it just depends on, you know, what your homework system is. I personally don't care if on a test, if you're one of my students, I don't care if you write it like this, but I know like our homework system might make you write it like this. I'm not sure. Some homework systems do, some homework systems don't. Okay, so for this quadratic, so I've got 2x squared minus 3x equals -6, and there's a hint here to use the quadratic formula. So to use the quadratic formula, first of all, the thing that you need to do that is that everything has to be on the same side. So I'm going to rewrite this as 2x squared minus 3x plus 6 equals, equals 0. And now with the quadratic formula, so what you've got to do is you have got to, well, first of all, let me just make sure you remember the quadratic formula, so I'll just write that down real quick. So here's the quadratic formula. So you have to identify what's in the A, B, and C position, remembering that quadratics have the form ax squared plus bx plus c equals 0. So what's in the A position? That would be 2. What's in the B position? That would be -3. And then in the C position is 6. So now what I'm going to do is I'm just going to plug all of this good stuff into the quadratic formula. So let me make some space. All right, and so let's get this party started. Okay, so I've got x equals, so this is supposed to be -b, so that would be -3, so that would be +3, plus or minus the square root of -3 squared minus 4 times a times c, so that's times 2 times 6, all of that divided by 2a, which will be 2 times 2. Okay, and so now it's just a matter really of sorting out the arithmetic here, right? So this becomes x equals 3 plus or minus the square root of 9 minus 48, all of this now divided by 4. And so then, let's see, I'm running out of space here. Let me make some room. All right, so this becomes x equals 3 plus or minus the square root of -39 over 4. Okay, and so now there's really not a whole lot extra we can do with this because the square root of -39 cannot really be broken down outside of taking out the negative. And then you could just turn this into two solutions. So the final answer here, if I want to write it as the two separate solutions, will be x equals 3 plus I times the square root of 39 over 4. and actually you could break this up into two pieces, I guess. So if we wanted to be technical, this would be 3 over 4. Oh my god, cannot write. Okay, 3 over 4 plus the square root of 39 over 4i, and then just change it to a negative sign in the middle. Boom. Okay, and so that would be using the quadratic formula, and like I said, this one is just, there's like nothing else we can really simplify, so that's that. And the last type of, this isn't quadratic, but we'll call it pseudo-quadratic. I just wanted to kind of remind you of some creativity. So what if I have x to the 4th minus 16 equals 0, and I want to factor and use the square root property? What does that even mean? Okay, so to factor this, so this would factor as x squared minus 4 and x squared plus 4. Okay, so I want to solve for x here. Now, notice this part here I can factor further. So I'm going to go ahead and do that. So I'm going to write this as x minus 2, x plus 2, and then I've got x squared plus 4 equals 0. So I can see from what I've written down so far that I have the solutions 2 and negative 2, right, from these two factors. So I've got x equals 2 and x equals negative 2. Now what do I do about this? This is where the square root property can come in handy. So what I can do is I can set this factor equal to 0, and then to use the square root property, remember the x has to be isolated. Do you see how you can use the square root property now? So now when I take the square root of both sides, I get x equals plus or minus 2i. And so now I've found 4 solutions to this. I've got plus or minus 2i and these 2 solutions right here. So there you go. Okay, and so that brings us to the end of this video. So if that was a helpful review, then consider liking this video. I have an entire series where I went very slowly over the imaginary numbers and all of that. So if this was a little too fast for you, I will drop some links in the description. And you can go through imaginary numbers at a much more in-depth pace. And okay guys, so that'll take us to the end of this video, so I will catch you in the next one.